All right, this is the concluding part of part 2 of the World Great Lakes and the Slurry sediment deluge. I got to get talking quick, and I'm just picking up for where we left off last time so I can try to make it through this video. Then we're going to move into the part 3 of the series, which is going to rip your head off even more. Now, while the lakes are pulsing, the Cordillera pops in sync. Missoula megafloods roar down the Columbia. Bonneville flood rips down the Snake in Columbia. Yellowstone melt drain events flush at the same time. All of that is carving to the Pacific as the Great Lake plume runs east and north, not downstream, synchronized taps. Add the Arctic loop. Mackenzie outflow rides the Alaska coastal current into the Gulf of Alaska, dusting British Columbia and southeast Alaska with fine particulates. And here's the cork everyone forgets. California's Island Canal, massive slurry riding the Sacramento, San Juan, plus longshore transport, silts the bay's mouths and straits, corks the old canal. I showed you guys right there. And welds California back into the mainland. That's why the San Andreas sits where it does. It's a fault scar over a cork canal. That combination is how you get 40-foot burials in western cities. Multiple feeds, slurry feeds, arrive together, local megafloods, Missoula, Bonneville, coastal slurry, atmospheric mudfalls, and ground collapse and saturated bay muds. Facades don't sink slowly, they vanish in one window. Here's the one line I want you to remember. This wasn't one hose. This reset opened several westbound conveyors at once. Missouri sheet floods, Columbia mega floods, Arctic to Alaska returns, and atmospheric mudfalls while Delta silting cork California's canal. That's how you bury both coasts in the same clock. The smoking gun, the Great Lakes. Now, the piece that made this click for me lives on the other side of the continent, the Great Lakes. I started by making the obvious. The dune belts on the windward shores, your spoil piles. Then I drew a simple line inward from those dunes toward the center of each basin. And I asked a dumb question that turned out to be the right one. Do we see islands sitting on those inward lines? Lake by lake, yes. 5 for 5. So I thought, okay, if there was an excavator, because these would have been 150 to 200 miles long, how could I find evidence that these excavators were there? Well, there would be pillars towards the closer you got to the dune, and they would go lower as you went, right? Well, over time, these pillars, if they removed everything else, these would be the only thing there, or if they rusted away. But the pillars would remain, and that's what, think about how big this thing is, that's what would later become islands. So Lake Superior, Isle Royal, and the Apostle slate chain sits exactly inward from the eastern northern dune belt. Michigan, the Sleeping Bear, Indiana Dunes arc points inward to Beaver, Manitou, Washington line. Huron, dunes around Georgian Bay point to Manitoulin, the largest freshwater island on Earth. Think about that. Like a backbone parked in the basin. Lake Erie, Western Dunefield, Bass Kelly's Pele Cluster right along that line. Lake Ontario, South Shore Dunes, Wolf Amherst, Thousand Island Lakes, like a discharge gears out the outlet. 2 lakes even show dual vectors. 2 sets of island lines, like 2 matching feeds to the same spoil pile, 2 excavators. At first I thought maybe that's just glacial accident, so I forced myself to do the math in public. Pick a 60-degree wedge point from the dune belt into each Great Lake. If islands were random, the chance that all 5 lakes have islands lined up in that wedge is only 2%. Add one more rule. Those islands sit in the right radius band where a frame would be, and the odds drop toward 1 in 10,000. We also get 2 full backbones parked where you'd expect to see it. That's why it looks like structure and not scatter. Uh-oh. Uh-oh, Josh, what are you doing here? That's not a trick. It's just geometry. Angle only test, the wedge, 2% for 5 for 5. Angle plus the radius band where a frame would sit about 40 to 70% of the basin width. The coincidence drops towards 0.01%. I don't need that to prove machines. I need it to prove non-random structure, and that's exactly what it does. Now layer on the material evidence. The two backbones are geologically anomalous in the right way. Isle Royale is long, narrow ridge of billion-year-old rift basalts with strong magnetic anomalies. It behaves like a spine. Manitoulin is a massive, resistant carbonate block that anchors the Niagara escarpment, a foundation piece in the middle of the basin. If you left a planet-scale excavator in place and everything but the vertical stabilizers rotted or collapsed, this is exactly what you'd expect to be left with. Pillar islands with sediment and organic built around them, misread today as ordinary bedrock highs. That's the working model of the dunes. Blocking that one that time. Dunes equals spoil, islands equals frames or pillars, arrows inward equals the path of the cut. Here's where the cartography nails the timing. We pin specific map makers and dates and they collapse into the same corridor. California, island to peninsula. 1780, Antonio Zada's still shows California as an island. 1790s, William Fadden keeps the island still alive. 1804 to 1807, Alexander von Humboldt surveys New Spain and proves it's a peninsula. 1812 to 1814, Arrowsmith, 1812, and Pinkerton in 1814 finalized the correction in atlases. So California flips from 1780 to 1807. That's 27 years. Sahara, rivers and lakes versus the Great Desert. 1780, Robert Bond still shows rivers and interior lakes. And I asked the AI to actually show where the lakes were. Not sure if it's correct. 1798, James Rennell depicts the interior desertified, the transition map. 1814, Pinkerton cements it as a great desert. So the Sahara flips where it still had rivers and some lakes from 1780 to 1798. That's 18 years. Overlap both timelines, sit inside. 1780 to 1807, that's the razor's edge. 1780 is the year you still see the old world forms. California as an island, Sahara with rivers. 1798 to 1807 is the correction window, peninsula to desert. By 1814, the new reality is locked, the map canyon. Maps are receipts. They're telling us the reset didn't crawl, it clicked. So how did I get here? I didn't start with machines. I started with patterns that refuse to be random. Spoils first. Dunes make sense as piles, not origins. So I trace the lines from piles inward. Islands on those lines. 5 lakes, 5 hits. Then I added the radius where the frame would sit. The odds collapsed. Backbones. 2 basins have full-length spines at the right distance. Isle Royale and Manitoulin. Material checks. Those 2 happen to be old, hard, magnetic, exactly in the way a surviving pillar core would be. Timing. Independent cartographers on 2 continents, California and the Sahara, flip inside the same 27-year window. Each step is testable. You can redraw the wedges yourself. You can check the island radii. You can pull Bond 1780, Rainier 1798, Pinkerton 1814, and look. You can magnetics map Isle Royale. And the moment you do, the picture stops looking like glacial noise and starts reading like structure. From here, I'm going to widen the lens. The same taxonomy we built for mountain stumps, bodies, dragons, spoil, and crystalline roots explains why normal mountains aren't normal. There's no such thing as a normal mountain. See you on the next one. Have a good one.